Hello students, hope you all are doing well. So in this series we will discuss about the chapter states of matter with mainly emphasis to the three major states that a matter can have. They are the solid, liquid and gaseous state. So let's begin with, and to mention for your convenience, I have used the demonstration model in this video as a teaching learning material so that you find it easy. I hope it will be an enjoyable journey for us. Let's begin. So, the four states of matter, there are mainly four states of matter. So what are they? Solid, liquid, gas and plasma. But the main three of them are solid, liquid and gas. As you can see, I have highlighted them in the list. So the basically what are the parameters or the attributes which contribute or cause the different states of matter? They are the arrangement of the particles, energy, the internal energy of the particles and distance between the particles inside a matter. I think this concept is bit abstract for you, but with as we gradually progress with the video, this will be clear. So from this slide, our takeaway is there are total four states of matter: solid, liquid, gas and plasma, and the three major of them are solid, liquid and gas. So what is kinetic theory of matter? Matter is made up of particles which are in continual random motion. So as we can see in the circular diagram, the molecules or the particles of the matter used to move inside the matter, and the speed of the movement distance on the depends on the distance, internal distance of the particles, and the deviation in state causes due to this intermolecular distance, speed of the matters and size of the particle. So let's move forward. So in this teaching learning method material, as you can see, there are three types of states have been depicted. So in the first class, as you can see, the particles are closely packed. In the second, they are more moderately close packed, and in the last one they are very loosely packed. So let us see how the chapter gradually proceeds. So the first type of state that comes is the solid. Particles of solids are tightly packed and vibrating about a fixed position. As you can see in this picture, that they are moving very slowly. They are moving very slowly as they are closely packed. Similarly, let us see in the teaching learning. So another characteristics of solids are solids have a definite shape and a definite volume. Because they are closely packed, it is hard for them to change their shape, and the volume is also fixed. So moving forward to the teaching learning material, as you can see in this case here, in case of solid, what happens? The particles are very closely packed and they cannot move freely, so they provide it's a definite shape. And here I have also mentioned the several characteristics. Once you see the video that describes this preparation of the model, you will be able to read them, and I think this is I think this will be also helpful because it is an intermolecular diagram where it shows there is hardly any intermolecular space, so the shape is defined and volume is also specific that cannot be changed. Moving forward, our next state, that is liquid. Particles of liquid are tightly packed but far enough apart to slide over one another. So in this, here we can see in this video that the particles are bit loosely packed. What we have seen in case of the solid, in case of liquid, the intermolecular places are a bit more. That is why there are more movement inside the liquid. Liquids have an indefinite shape. So as we can know or see in our daily life, water has no shape, milk has no shape. In whichever container, when we pour it in a glass, it takes the shape of a glass. When you take it in a bottle, it takes the shape of a bottle. So it has no definite shape, but definitely it has a definite volume. So we cannot accommodate 2 liters of water in a 1 liter bottle. We have to accommodate 2 liter of water in a 2 liter bottle. So this is why it has no definite shape, but it has a definite volume. What is volume? The area or the total space it occupies. Now moving forward, here in case of little liquid, what we can see, there are moderately close packed. The number of molecules are less than what we have seen in the solid. Then similarly in the intermolecular diagram, there are more gaps with respect to or in comparison with the solid particles, and there are gaps in between, so the particles can move freely. Similarly here also I have described the characteristics of the liquid state of matter. Moving forward to the next step, that is the gas state or the gaseous state. Here as you can see in this video, that there are more intermolecular phase, so that and very the number of particles are very less, so they can move freely inside the matter. And this is why particles of gases are very far apart and move freely, and gases have an indefinite shape and indefinite volume. So that this is why we can pressurize more and more gas inside the cylinder. The volume can be compressible. Moving forward, here in this teaching aid, as we can see in this last glass, there is hardly few number of molecules and the number is very less. Here in the intermolecular diagram also, there is the least number of particles we can see, and there is huge gaps in between the particles, so that they can move freely inside the space. And like the last two types, here also I have jotted down the characteristics, what you can refer later on for your future references. Now here so far we were discussing about the states of matter, but in this slide we will see how these particular phases changes among themselves. So solid to liquid, when a matter goes from solid state to liquid state, the process is called melting, and heat goes into the solid, so it melts. When the change is from liquid to solid, the reverse way around, then it is called freezing. So heat leaves the liquid as it freezes and condensifies, and it turns into a solid. So here we have seen solid to liquid, that is melting, and liquid to solid, that is freezing. Moving forward, phase change between liquid and gas. So liquid to gas, when the shift is from liquid to gas, it is called vaporization, which includes boiling and evaporation. It goes into the liquid as it vaporizes. Coming to the second one, gas to liquid. The process is called condensation. When a gaseous material, upon leaving the heat, condensifies, and by the process of condensation, it transforms from gas to liquid state. And the last one is solid to gas. This process we call sublimation. Heat goes into the solid and it sublimates. And a good example of this one is camphor. When camphor is heated, it goes gaseous state. So this is an example of transformation from solid to gas, and this process is called as sublimation. Now what happens if we raise the temperature of the super high levels? And you will soon understand why I am going into this, because if you can remember, there was total 4 stages I mentioned, but 3 stages I have explained so far. So there were 4 stages, and the last one was plasma, and I haven't described plasma yet. So this is the answer. Will everything just be a gas? Whether if a solid or liquid is heated in higher temperature like 1000 to 10,000 degrees Celsius, what will happen? The answer is plasma. The plasma is an ionized gas where the particles inside are in ionized form. A plasma is a very good conductor of electricity and is affected by magnetic fields. Plasmas, like gases, have an indefinite shape and indefinite volume. So both the volume and shape are indefinite. and plasma is the common state of matter. So what is the common state of matter? Plasma is called the common state of matter. Now here is a pictorial diagram where the four states of matter have been jotted down in one slide. So solid tightly packed in regular pattern vibration but do not move from place to place, the particles inside. In case of liquid, close together with no regular arrangement, vibrate, move about and slide past each other. What happens when more energy? As you can see, the E mentioned here, this is the outside energy. In this case, this is basically heat. So what happens when they are heated? The gas, well separated, the molecules are with no regular arrangement, vibrates and move freely at high speeds. And in case of plasma, what is happening? This is a ionized state. This is a higher stage and this is a ionized stage when more heat has been applied. So again we are coming back to our teaching learning material. Here we can see the major three types of states. One is solid, where the intermolecular space is less, the volume is definite, shape is definite. Then we have liquid, where the number of molecules are bit less, intermolecular space is moderately high, the shape is not definite but the volume is fixed. Lastly, we come to gases. Here the number of particles inside are very less, there are very huge intermolecular space, it has neither definite shape, neither definite size, and lastly there is no definite volume. I hope this explanation have been helpful for you. If any further query is there, please feel free to ask your questions in the comment section of the video. Thank you. Thank for your patience listening. Thank you for attending the class. Thank you so much.